Have time today for you to do your teacher evaluations. If not, we'll do them next Tuesday. But that's our review day. So we are fast approaching the end of the semester. So today we're going to begin and end chapter 19. That means your homework is due next Tuesday because obviously we do not have class on Thursday. Your homework is due Tuesday. Tuesday we will review for the multiple choice section of exam 3, which is on Thursday next week. Stephen has a review for the short answer portion, which I believe he's having it on Monday and Tuesday next week. Let me go outside the door and the schedule. I know, it should be a nice schedule here. Next week you can go Monday or Tuesday for the short answers. Tuesday in class we'll review for the multiple choice. Your exam 3 is on Thursday. Then I won't see you between that exam and your final exam, which is on Tuesday, December 10th at 11:30. So don't come at noon. Okay, our exam is from 11:30 to 1:20.
On the 10th.
On the 10th. That means there could be someone coming in here at 1:30 to give an exam. So because exams are an hour 50 minutes and class is hour 15 minutes, we have to follow the school schedule. Okay, so today we'll begin and start 19. Next Tuesday we will review and your chapter 19 homework is due. Thursday next week is your exam, and the following Tuesday is your final. Okay, there is no review for the final. I will talk a little bit about it on Tuesday. Your final exam is comprehensive. It has 0 multiple choice. It is all short answers, and it is very similar to the review that's online. It's the only review that's very similar to the exam. So here's the good news. If it's not on the review, it's not on the exam. So you don't have to go look through all that book. You just, if I were you, I would print out the review and I would do it 10 times. I would do it again and again, not so that you're robotic, but that you know why you're doing it. First you're gonna have to start looking it up, right? How do I make classes? I don't remember, that's from the beginning of the semester. But you're going to go back over and then why is that 1.96? Why did I pick this formula? But I will tell you, it is like the tip of the iceberg. When we do exams, we dive deep into the material, T-scores, finite correction factors. The final exam is not like that. It's a skim across the top of all of the topics. Do you remember what a mean is? Can you give me a confidence interval? It'll be a confidence interval for a mean. It will use a z-score. Probably use a z-score you don't even have to look up, right? But it will be a basic of everything. But it's like, do you remember all of it? Because you need to kind of go back. At the time when we were going through it, the waters were a little muddy. We're like, what the heck? But now we've been using stuff so much, when you go back and look at it, you will see how much you've learned. Okay? So I will talk a little bit more about it next week. But you can come to the final review on that Saturday, but what I would say is work that final review. There will be several of you who should be able to get 200 out of 200 on that final exam. That's not true of exam 3. Exam 3 is probably the hardest one. Okay, so you need to study hard, study this weekend, go to reviews so that when you go to the reviews on Monday and Tuesday, you know what questions you have about what you didn't understand when you reviewed with Stephen. So you can say, okay, can you go over that again? Can you do another one of those? All right, so chapter 19 has covered the last course competency that is part of our class, and that is statistical methods for quality control. So quality control has become more and more important as the world has become more global. Okay? When I was young, you didn't have the option of buying something at Amazon, right? You'd go to your bookstore. If they didn't have it, you'd order it. You have to wait for it to come in. So if they didn't do very good inventory, I'd still have to be their customer because there's like one bookstore in town. And so, but now we're not very patient. If someone doesn't have it, I'll order it online. I'll go get it someplace else. So customer service and quality control has become more and more important as your customers have more and more choices. Okay, some people don't give you a second chance. So some of you might have been to a restaurant many times and had a nice meal, and then once you ate then you got food poisoning and you never go back. Right? Some people do that. Right? Has anyone ever had a bad meal someplace and then not gone back? Right? That you just say, okay, I'm not gonna do that. So you have too many choices. You know, when I was a little girl, we used to take the train once a month into a big town called Guilford. And I would go with my mother. We'd always eat in the same place. And so before she passed, I was back one with just her and I. And I'm like, we went shopping. I'm like, oh, we should go. It was this place that was like a baked potato bar restaurant. And we used to go there every time we went to town. And I said, oh, I wonder if it's still there. And she said, I haven't been there in like 5 years. And I'm like, oh, why not? And she said, because the last time I went, my baked potato was hard. Now, my mother's not quite as outspoken as I am. So she was a very quiet British lady who would never complain. But I'm like, she'd just never go back. I'm like, don't you think they'd rather you give you a new potato and that you'd go back? She never didn't go back. So some people don't give you a second chance. Like, if you mess up, that's, you know, you've lost that relationship. And it's a lot more expensive for you to find a new customer than to keep your current customer. Right? The amount of marketing and that type of thing to get new customers is expensive. So quality control is very important, more so today than it ever has. So companies need to monitor, right? And so we will sample. This is more manufacturing type based, but like I'm pretty sure Colton didn't make sure that his energy drink had, how many ounces does it have? 16 ounces, right? Did you check?
I wanted to.
But so we need to check, right? So we need to make sure that our process is going consistent. And this has been around for a long time, long before calculators and computers. This has been around since like the 40s. So I'm going to use the very last table in our booklet, which is a little antiquated and odd looking, but they still use it today. So we're going to decide. So if I go through and I find that all of a sudden I test a few cans and I think that they're not have 16 ounces in it, maybe all of a sudden they've got an average of 17 or 18 ounces or 15 ounces. I have to decide, is this like normal variation or is this something has happened? Is there a cause that I can assign to this? Maybe something went wrong on the machine and now they're all being overfilled. Then I would need to stop production and fix it. Okay, so there is normal variation that happens because we're not perfect. Even machines wear out a little bit and things start to change a little bit. So there are common or normal variation, and then there are assignable causes that you need to stop. So you've probably all watched Undercover Boss, right? Where the boss, the CEO comes in and he tries to work, or she tries to work on the production line. I saw a couple, one was like White Castle Burger, I think it was. And he's trying, as it comes down the conveyor belt, he's trying to stuff the 12 burger things into the bag, and he's just not quite fast enough. And the machine comes down to seal the bag, and it chops like the last 3 burgers in half because he doesn't have it in the bag fast enough. And so if someone's not there to check and that gets through to the customer, then you have a problem, right? So I took, when I was in charge of DECA, have you guys been to the Amazon warehouse? We did a tour of the Amazon warehouse. The Amazon have 3 warehouses about 67th Avenue and Buckeye. Somewhere that's just not on my normal driving place. And each warehouse is 28 football fields big. And the warehouse that we went to only sold small items. So if you wanted a bike, it didn't come from here. Okay, it had small items. And so I thought it was just going to be this really orderly system. And so first, you can't take any photos. It's very, very strict. You have to have your hair tied up, the closed-toed shoes. They're very strict about it. But anyone can go. And if you go, like, it's absolutely fascinating because it's absolutely organized chaos. When, first of all, because it's so big, they have tricycles. So if people have to go from one end to the other, and they carry, let's say, a laptop, they have a tricycle with a bigger basket in the back and people ride it around. They have a little train that takes product around. But so these people, they pull stuff for your order. So let's say you ordered a book and a box of vitamins. Okay, so you might be pulling, and they know from your GPS, they know where in the warehouse you're standing, and they know exactly where every item is. But every bucket has what appears to me to be random nonsense in it. So I was looking, and at one bucket there, it had like a book, it had prenatal vitamins, it had dog poop bags, it had like a baby toy, just random what seemed like unrelated stuff. And so they know that this person's standing in this aisle, and they tell this guy, pull this thing and pull that. Now he might pull the book for your order, and he might pull the vitamins for somebody else's order, but then they go up, it's like Willy Wonka's chocolate factory. It goes up a conveyor belt, and then we went upstairs, and it was kind of quiet because they had many, many lanes and only one was open. And there's a lady standing at the computer, and she has this computer screen, and then here she has a stack of different sized padded envelopes and a different size of boxes. And the computer tells her which one to pull, and she can pull, and she can do it like the pizza people, make that into a box like this. And then along come the products. She puts in your book and your vitamins, and then it goes on, and then there's a machine right there that seals it. She doesn't seal it. Now, your product is sealed inside a box with no label. Yeah, it hasn't gotten that far yet. So imagine if something happened and it got jammed or something went wrong, then all of us and everyone whose order came behind could be off a label. We'd all get the wrong items. So it's really fascinating, especially if you're going to be in supply chain management. They do tours on Tuesday afternoons, and takes a lot of advanced planning if you're doing a big group, but they often have big groups booked, and then they've got 3 or 4 extra spaces. So if you ever have a Tuesday afternoon, it's very, very fascinating to watch how it kind of all comes together, because I don't think it's what you would expect it to be. But you could have something went out of control, right? If something went wrong and the boxes got mixed up, then the labels would be all wrong. So then you need to know. I once ordered a shirt, and when it came, the outside sticker on the bag said small, and when I opened up the plastic, it was an extra large. And so I sent them a picture, look, it says small. So the person pulled something that said small, but some have been stuffing extra large shirts into bags and then putting small stickers on. They're gonna have probably a big issue with that, right? Especially if they did. And they even said to me at the time, donate it. It wasn't worth their money to come pick it up and ship it back to them. So they said, just donate it and we'll send you another one. So when things go wrong, right, you're going to have to stop. So we're going to create what are called control charts. That is, if we want, like if his can says 16 ounces, honestly, they probably set the average to be 16.05, right? They don't want to be 16 because half of them will be underfilled and they'd be in trouble. So let's say that it is set at 16.05. We're going to calculate an upper control limit and a lower control limit that we will find as acceptable boundaries. And as long as our sample that we get is something in here, we're going to let it keep on operating. But the second we get one item up here or down here, we are going to shut down production, because these are means or averages that we're plotting, right? And so if the average of however many, let's say we take 30 cans. If the average of 30 cans is down here, this is not good news. So we'll take this as acceptable, and anything outside we shut down. So we're going to calculate the upper control limit and the lower control limit. And what we're trying to do when we calculate these limits is finding plus and minus 3 standard deviations, right? Because with our bell curve, 99.72% of observations should be within plus and minus 3 standard deviations. So if something's outside of that, that's an outlier. That's abnormal. And so that's why you're going to consider it out of control. In real life, they also would shut it down in these scenarios. If they start to see a pattern like that, they might shut it down, because these are supposed to be random variations, right? They're supposed to be some up, some down, and so there should not be a pattern. So that would also, even though it's not outside in real life, that would shut down a production. This would also shut down a production. Okay, if they have 5 points going in the same direction, because random, it's like, you know, if you tossed a coin and you got 5 heads, that's weird, isn't it? To get 5 heads in a row with no tails. This is like getting 5 heads in a row, and it shouldn't happen. You should get a head, a tail. Might get a couple heads, but to get 5 heads would be a little weird. The probability of that happening by chance, right, is 1 out of 2 to the 5th. It's like not very likely. So if they have a pattern develop, they shut it down before it goes outside in real life, because they're trying to prevent, right? Because then they have to throw the product away if they find that they're all. I've sampled 30, but what if this whole hour it's been off? Then I have to throw all that product away. I mean, if it's got too much in it, it's fine. If it's got too little in it, I cannot sell it. I would have to trash it. So, as I said, we're trying to get plus and minus 3 standard deviations, or 3 standard errors, since we're going to be taking samples. So 3 standard errors. And you will, hopefully, it will just juggle along between the 2 blue lines. Okay. So we're going to talk about control charts for variables, which are numbers. And then we're going to talk about, which will be means and variance stuff. And then we're going to talk about control charts for attributes, and that is proportions. Okay. So when we do control charts for variables, we're going to do 2 charts. We're going to do an X bar chart and an R chart. An R chart standing for range. What is range again? From chapter 3. Highest minus the lowest, right? The distance between the highest and the lowest. So remember, this was developed in the 40s before they had computers and calculators, and they don't want to calculate standard deviation all the time. So they used the range, and they still do. So think about, let's say I make jars of jam. Okay, and it says 12 ounces on my jar of jam. Okay, there's my jar of jam. And I take samples. I'm going to take samples of 2 for simplicity's sake. So if I take sample number 1, I take a sample every hour. Okay, so I take a sample at 1. The first sample I take, one has 16 ounces in it, and the other has 8 ounces in it. Okay, what would the mean be of this sample? The mean would be 12, right? So when I'm looking at a mean chart, this would probably pass the mean chart, because it's got the mean is exactly what it's supposed to have in it. But when I look at the range, I don't want there to be a range of 8 ounces between my 2 jars, right? I want one and then, right? So this would fail the R chart, but it would pass an X bar chart. If I had taken a sample like this, what is the mean? 8 ounces. And what is the range? 0. This would pass a range chart, because we like things to be all the same. But it would fail the mean chart, right? We don't want jars of jam that say 12 ounces to have an average of 8 ounces in it. Okay. So, hopefully, right, this would pass both. This would be ideal, right? The mean's 12, and the range is 0. This would pass both of them. What about this one? Ounces. 12 and 16 ounces, right? That has a mean of 14 ounces, and it has a range of 4. It would probably end up failing both of those, because you don't want there to be an average of 14 ounces product in every jar of jam, because you're wasting product. They're paying 12 ounces. You're giving them 16.7% more product than they're paying for, and they don't even know you're giving it to them, right? They're not even grateful for it, because they don't know it's there. So we're going to do samples, and they have to pass both charts for you to continue producing. If they fail one or both, you shut it down. Call an engineer and fix my machine.
Is there like a standard acceptance?
So we're going to calculate them at plus and minus 3 standard deviations.
Yeah.
You know,
Okay.
right?
All right.
And if your standard deviation's big, you're going to have to set your mean higher, because remember, we don't want, let's say, more than 5% to be underfilled, or we're going to get in trouble with the weights and measures department, right? So we got to, if we don't have a very good, if our machine varies a lot, you know, has a big standard deviation, then we're going to have to set the mean to be a little bit higher. So I said the mean will always be higher than what it says on the label. Because if the mean is what it says on the label, half of them will be underfilled and half of them will be overfilled. And they can't have half of them underfilled. So to get the X bar chart, what we're trying to do is the mean plus 3 standard errors, right? The standard error is the standard deviation over the square root of n. But remember, I'm no longer doing finite correction factor. So you don't have to worry about that. Okay, so you have one homework question that is like this. But to use this formula, you need to know the population mean and the population standard deviation. Okay? So this says KJW has a production line that fills cereal boxes. When in control, the mean filling weight is 16.05 ounces, so the box probably says it has 16 ounces in it, right? And the process standard deviation is 0.1. The filling weights are normally distributed. Suppose a quality inspector selects 6 boxes to determine whether the process is in control. So you just plug your numbers in. The mean is 16.05 and you add 3 standard errors. The standard error is 0.1 divided by the square root of 6. Okay? So to get the upper control limit, you take the mean and you add 3 standard errors, and you would get this to be 16.17. Okay, then you take the mean and you subtract 3 standard errors, and this is 15.93. Okay, so as long as every time I take a sample, I sample 6, as long as the mean is between 16.17 and 15.93, I'm going to let the process continue to operate. Okay. But if I get one spot up here and down here, I'm going to shut it down. And so in the text, there is sample number 5 is out of control. Okay. But you would plot your point. Here is usually time. When you're talking about production, it's usually time on this, 7 a.m., 8 a.m., 9 a.m., every hour you take a sample and make sure things are functioning right. So this is often time in quality control. Okay, so one homework question like this where you do the mean plus 3 standard deviations. So that's very simple. In most cases, you don't know the population standard deviation and the population mean, and definitely in the 1940s, they didn't know that. Every hour, they didn't have time to recalculate the population mean and standard deviation by hand, right? That would have been a lot of work. So they have come up with ways to estimate 3 standard deviations. Okay, and it's been a good enough and a quick answer for people to calculate how to estimate plus and minus 3 standard deviations. There we go. All right, so if you don't know the population mean or the population standard deviation, this is the formula that you're going to use, and you are not seeing double. This is X with 2 lines above it, and that stands for X bar bar. That is the mean of the means. That is, if I asked you what is X bar bar here, it is what are the means of these means, right? So to calculate the mean of these numbers here, what would you do? You would do 12 plus 8 plus 12 plus 14 divided by 4. Okay, so whatever that is, that's my X bar bar. It's also called your grand mean. It's the mean of the means. Okay, so what you just did when you divided by 4, and this is the part that's the only hard part, because this is actually a very simple chapter of plug and chug numbers. Here's the hard part. The formula for this X bar bar is the sum of all the sample means divided by K, where K is the number of samples that we took, right? We divided by 4 because we took 4 samples. A lot of students want to put N, and they want to put 2. Okay, having a grand mean of, I don't know what this is, let's see, 20, 32, 46. So that is 11.5. All right? Check my math. Is it 11.5? Okay, so that's what the grand mean is. If I had divided by 2, I'd have got a grand mean of 23. That's a stupid answer, because none of these numbers are 23. So the average of them can't be 23. But students' biggest issue is deciding between N and K for the formulas in this chapter. N is how many observations you have in a single sample. And K is how many different samples did you take. Okay, so N is 2 in our scenario, isn't it? N is 2. Each time I took 2. And my K is 4. Okay, if you get those backwards, that will lead to issues in a lot of ways. So you need to practice, and I try to show you some different examples with different wordings that you know. All right, so here's, the R chart. So get the upper, sorry, I didn't finish it. You also need to add, this is a factor that's on a table on the back of your booklets, okay? So to look up, it's very simple to look up. Go to get your booklet out and turn to the very back page. And A2, all you need to know is N. Okay, and you go to A2 and you look it up. But the problem is if you look up K, you're going to get the wrong factor, right? So you got to look up N. So you got to know N will determine also what factor you look up. So it just says, what is N in the left column, and then you go over to A2. Okay, so how many in this case, my N was 2. You go over to A2 and it says 1.880. That would be the factor that I use. R bar is the mean of your ranges. So these were my ranges. 8, 0, 0, 4. So how do I calculate the mean of my ranges? Would be 8 plus 0 plus 0 plus 4 divided by 4, which is 3. The mean of my range is 3. You just plug it in the numbers. Okay, but if you get N and K mixed up, this is wrong, and this is wrong. Okay. So you've got to be very careful with your N and K. That is an X bar chart. If it fails the X bar chart, you shut down production. But you still run an R chart, because the R chart tells you different information, and it may give information to the person who's coming to fix your machine about what is wrong. Maybe it means something different if X bar and R are out of control, or if just one is, so they might know how better to fix it. Okay, so the R chart, again, we're going to come with an upper and lower control limit, is R bar, which you've already calculated when you did your X bar chart, times the factor D4 and D3. So again, it's just to go to your N and look up D3 and D4, the uppercase ones. See, there's a lowercase D3. We don't do that chart. There is one in our chapter, but we don't have to cover it. So we're not going to be using the lowercase D2 and the lowercase D3. We're going to be using the A2 column and the uppercase D3 and the... Oh, I thought it was going to be like a burglar, like we had to evacuate the building.
No, sorry about that.
Uppercase D3 and D4, okay? Oh, we don't need that today. All right, so I'll go do an example with you. This example is most like the one on the final exam. And then the one that we do together is most like the one that's on exam 3. Okay, so this says 5 samples of size 7 are chosen. Okay, that's the first few words. 5 samples of size 7 are chosen. What is N and what is K? What 5 is what? 7 is N and 5 is K. 5 samples of size 7. K is 5, N is 7. Okay? And then it gives me the means. So 6.2, 7.3, 8.1. So it's giving me these numbers that I calculated down here, right? It's not giving me this individual data. It's just giving me the X bars and the R's. Do you agree? Okay, so we need to calculate the mean of the ranges. So if I'm adding 5 numbers together, isn't it quite apparent that I should divide by 5 and not 7? However many numbers you're adding together, that's what you need to divide by. Okay, so to get the mean of the means, you would add 6.2 plus 7.3 plus 8.1 plus 7.2 plus 6.3 divided by 5, which gives you a mean of 7.02. If you divide it by 7, you would get a number that's not sensible. You would get a number that's smaller than any of your means. So the mean of the means cannot be smaller than all of the means. And then we add up the ranges and divide by 5 to get the mean of the ranges. So we get a grand mean of 7.02 and a mean of the ranges of 1.48. We just plug in the numbers.